All right. Second for the double, looking at 905. Chapter 905. So we're looking at trigonometric equations. So we're thrown in, we're not given any new information here. We're just sort of applying what we already know in a different way. So let's have a look at how that works. So part A, we're asked to solve sine x equals 0.34. Okay, well, first of all, I've got a positive result. So I say to myself, what quadrants is sine positive? So all stations to central. So sine can exist in the first and second, or positive sine exists in the first and second quadrants. So I'm going to first equate to find out what my x is. So to find out what x equals, so I need to take the inverse sine of the other side, 0.34, which gives me 19 degrees. 19 degrees and 53 minutes. So that's my principal solution. But there's also a second solution, as we said, because sine is positive in both quadrant 1 and quadrant 2. So we've found quadrant 1's results, but we also have to factor in quadrant 2's results because it could possibly be in 2 as well. So to do that, in quadrant 2, I'm taking away from my closest horizontal, which is 180. So I'd have my 180 or my obtuse option of the angle as well. So it either is going to be 19 degrees, 53 minutes, or it's going to be 160 degrees, 7 minutes. So that's how I solve A. Solving B, between 0 and 360 degrees. So cos, they're telling me, is positive. So again, I'm asking what quadrants is cos positive in? It's positive in quadrant 1 and quadrant 2. So we've got 0 and, well, 0 plus our angle and 360 minus our angle for quadrant 4. So cos x equals root 3 over 2. Well, to get my degree measurement for x, I can tell that root 3 on 2 is an exact value. So I need to have a look at my triangle. So root 3 over 2, and cos is a on h. So I must be looking at this angle here, or 30 degrees, because my a is root 3, h is 2. So this is technically like saying find cos of, oh, sorry. That tells me that my angle, or x, equals 30 degrees. So x equals 30 degrees. So I know x equals 30 degrees. Now I need to factor in my quadrants. So in the first quadrant, which is where cos is positive, it is 0 plus our angle, or 30 degrees. In the second quadrant that it's positive, it's the in the other quadrant it's positive, it's the fourth quadrant. So fourth quadrant is 360 minus my angle, or I'm going to get, it could be 30 degrees, or it could be 330 degrees. So again, I've got two values where this could exist. Again, make sure there's a little tag there that your calculator is in degrees mode, considering we're given a degree parameter. And the next question we'll look at given a radians parameter. So let's look at C now. Okay, firstly, tan -1. So that tells me tan must be negative. So tan could be negative in the sine and the cosine quadrants, or quadrant 2 and 4. So to work out what theta equals, I need to work out using my exact triangles, what would give a 1 value. Now tan is O over A, so I can tell that 1 divided by 1 gives me 1. So I can safely say that theta then must have been taken from one of these angles here, or 45 degrees. So theta must equal 45 degrees. Now that I know theta is 45 degrees, I need to factor in my quadrants. Now tan was negative, so we're looking over in our unit circle, we're looking here at quadrant 2 and quadrant 4. So quadrant 2 is 180 degrees minus theta. So 180 minus 45 could be one option. Or in quadrant 4, it's 360 minus theta, or in this case, my theta is 45 degrees. So I could have two options, and my options are 135 or 315, I believe, 315 degrees. Perfect. Moving on. Solve tan x equals root 3, and this time I'm given the parameter of negative 180 and positive 180. So let me draw my unit circle again. So all stations to central. Okay, first of all, let me solve x. I'm given x is root 3, and we're dealing with tan. So tan is O over A. So I'm looking for, in my exact triangles, where I'll get tan equal to root 3, or root 3 over 1 would give tan. So I know that tan must be taken from this angle, or 60 degrees. So my x value equals 60 degrees. Now I need to factor in that we're dealing with root 3 is a positive value, so I know tan must be positive. So we're looking at quadrant 1 or quadrant 3. And I'm dealing with between negative 180 and positive 180. So positive 180, I'm just going to have the first quadrant, or this was just theta. So I could have x equals 60, or negative 180. Remember, starting at 0 here, around to this side. If I'm dealing with negative angle, then this is 180 take theta, and it's a negative angle because we're dealing with a negative angle. So it could be 60 degrees, or it could be negative 180 take theta, which is minus 60 degrees. So therefore, x would equal 60 degrees, or it could equal negative 120 degrees. So they're my two possible solutions. Two possible solutions for that question there. Okay, moving on to the next example. So solve 2 sine squared x, take 1, equals 0, between 0 and 360 degrees. So once again, I want to draw my unit circle on just to help me out. All stations to central. The other thing I'm going to have to know is back to my Pythagorean identities. I know that sine squared x plus cos squared x equals 1, which means that if I were to subtract sine away, cos squared x equals 1 take sine squared x. Actually, I'm not going to have to go that deep for this one, because sine squared x take 1 is not in the form of 1 take sine squared x, so I won't be substituting in. What I will be is I will just be rearranging this formula. So if I write it out, so I start with 2 sine squared x take 1 equals 0. Let's add 1 to both sides. So I get 2 sine squared x equals 1. Divide through by 2. I get sine squared x equals 1 over 2. And to get rid of my squared, I take the square root of both sides. So I get sine x equals square root of 1/2, which is the same as square root 1 over square root 2. I know that square root of 1 is just 1 over root 2. Okay, so let's just put my sine x in here. Now I can equate given my exact value here. So looking at my triangle, I need to find x when I get 1 over root 2. So 1 over root 2 with sine is opposite over hypotenuse. I can say 1 over root 2 happens in this triangle, and therefore my angle must be 45 degrees. So x equals 45 degrees. The next thing I have to factor in is whether it's positive or negative. 1 over root 2 is a positive value. And I also have to factor in, that 1 on root 2, because I've taken the square root, I could have positive or negative options. So sine in this case can be positive or negative. So positive or negative, meaning sine or this value could exist in any of the 4 quadrants, because sine is positive or negative in all 4 quadrants. So I know my x value, I know what quadrants it exists in. So in the first quadrant, remember, I just have theta. So x equals 45 in that quadrant. In the second quadrant, where 180 take my theta, so it'd be 180 take 45 degrees. In the third quadrant, 180 plus. So I'd have 180 plus 45. And the last one is 360 take 45. So I've got 4 options. 4 options for this question here. So x could equal just 45. 180 take 45 is 135 degrees. 180 plus 45 is 225. And 360 minus 45 is 315 degrees. So I've got 4 possible options for this question here. Next example. 2 sine 2x take 1 equals 0 between 0 and 360 degrees. Okay, so usually our domain is for x, but in this case our domain is for 2x, which essentially means we would find solutions by going around our unit circle twice. So all stations to central. So we'll see what that looks like as we work it out. So let's rearrange this equation first. So 2 sine 2x take 1 equals 0 is my original equation. So add the 1, so we get 2 sine 2x equals positive 1. Divide through by 2, we get sine 2x equals 1/2. And that's as far as I can get, remembering that my 2 value here just means I can go twice around the unit circle. So here I'm looking for an exact value where sine is 1/2. So I go over to my exact triangles. I've got 1 and I've got 2 here. So O over H, 1 on 2 would be from 30 degrees. So in other words, 2x equals 30 degrees. Again, remembering that the 2 means to go around the circle twice. So I've got, or that would mean 2x equals 30 degrees. I divide through by 2 to find what x equals. Therefore, x equals 15. And again, we're going around our circle twice. Okay, so we can do that, or we can solve straight for 2x equals 30, which I think might be the easier way to do it here. So let's do that first, and then we'll factor in, or we'll divide our answers by 2. So sine here is a positive value. So sine exists in first and second quadrants when it's positive. So we're going to have theta. This is the first time around our unit circle we'll have theta. So it could be 30 degrees or it could be 180 take theta. So 180 take 30 degrees. That was on our first way around the unit circle. Now coming around for our second time, we would have 360 starting here. So this quadrant would be 360 plus theta, or 360 plus our 30 degrees. And the sixth quadrant technically now would be well, to work it out, we'll do 360 plus 180 take theta, or take 30 degrees. So I've done my one rotation, added on 180, and then come back my 30 degrees. So here, x equals 30. It could equal 150, just simplifying. It could equal 390, or it could equal 510. Remembering that is 2x. 2x equals 30, 50, 390, or 510. Therefore, to find x on its own, I would just divide all by 2. So I could have done this before, which I started doing, and worked out that it was 15 degrees and would have, could skip this step. But whichever way you feel more comfortable, whether it's doing evaluating x first and then working it out, or working it out and then evaluating just single x rather than 2x is fine. So just dividing each of these by half, I get the following. So 195 and 255. Perfect. Moving on to the last example. So now we're looking between, we're looking at our domain being in radians. So make sure your calculator is in radians when you're equating these. Again, even though we're in radians, all stations to central doesn't change, but it now, instead of 180 degrees, we've got pi, and 360 degrees, we've got 2 pi. These are going to be solved similar to the first ones we did. So cos of x equals 0.34. Well, to find x, considering I'm given a decimal, not an exact value, I'm going to have to take the cos inverse. So x equals the cos inverse of my fraction, of my decimal, which gives me 1.224 radians. So here, my decimal was a positive, meaning that cos must be positive. So we're dealing with these two quadrants here. So I'm dealing with, this is just my angle, sorry. And this one is 2 pi take my angle. So my normal angle was what I received, 1.224 pi radians, or I've got 2 pi minus my 1.224 radians. Remembering we're working in radians now, so I don't have to manipulate it. So I could have 1.224, or I could have 5.059. Plugging that into my calculator and equating. Let's have a look at B. Okay, sine of an unknown angle equals negative 1 on root 2. So straight away, I can tell that that is a exact value. So I will be using my triangles to find my value of A, or the unknown. So the fact that I've got a negative tells me where that sign must be negative in this quadrant. So I'm dealing with quadrant 4 and quadrant 3. And I also need to find where sine has a value of 1 over root 2. So looking at my triangles here, 1 and root 2, sine is O over H. So I must be looking at 45 degrees, or 45 degrees in pi radians equivalent, given that 1 pi radian is 180, is pi over 4. So technically here, A equals negative pi over 4. Sorry, negative A is pi over 4. So I need to now take that into account over on my unit circle. So this quadrant here is pi plus theta. So my possible values for A equals to pi plus pi on 4, or 2 pi minus theta, which is 2 pi minus theta, which is my pi on 4. So I get 5 pi on 4, or I get 7 pi on 4, which is 2 pi, take pi on 4. Perfect. Looking at the last question, which is part C. Part C, I've got sine squared take sine equals 2. So I can see that sine squared minus sine equals 2 is in a quadratic form. So basically, I'm going to sine squared x, take sine x. I'm going to bring the 2 across. So I'm going to take 2 equals 0. And I can tell this is in a quadratic equation, similar to the equation like x squared take x minus 2 equals 0, except I'm replacing x with sine. So I can factorize that, and I should get sine x take 2 and sine x plus 1 equals 0, which tells me that for the left side to equal, or the left bracket to equal 2, sine x must, for the left bracket to equal 0, sine x must equal 2, or sine x must equal -1. Equals -1. Sine x equals 2 has no solutions, since sine only exists between 1 and -1. So between -1 and 1, sine exists. So sine never equals 2. So this is not a possible, or we cannot find a solution. Whereas sine x equals 1, has a sine x equals -1 has a solution. And if we think back to our graphs, sine equals -1 at this point, which from our standard sine graph, we know that this value is 3 pi on 2. So x would give us 3 pi on 2, and that is our only solution for that last question. So the last question is a bit tricky. We need to recognize firstly that's a quadratic. and then we need to factorize it and then solve through to find our x's. Okay, so good luck with 305.